Hello everyone and welcome to 7th grade Math Module 3, Expressions and Equations. In this video we'll be looking at Lesson 12, Properties of Inequalities. Our learning goal is to make sure we can write, graph, and solve one-step inequalities. This will help us to master Standard 7 EEB3 to solve multi-step real-life and mathematical problems posed with positive and negative rational numbers in any form using tools strategically, and 7 EEB4, use variables to represent quantities in a real-world or mathematical problem and construct simple equations and inequalities to solve problems by reasoning about the quantities. We will be departing from Eureka in this lesson. So, remember that inequalities are any sort of relationship with numbers and variables where your expressions on either side are not equal. Instead of using an equal sign, we use the less than symbol, greater than, less than or equal to, or greater than or equal to. In addition, we will be looking at our solutions on a number line. Normally, when you graph solutions to equations on a number line, you just place a dot on the number. When you're graphing solutions to inequalities, you would use an open dot whenever you're using less than or greater than. The open dot shows that the number you're plotting your point at does not include the number. So if m was greater than -5, we'd have an open dot on -5 to say that -5 is not greater than -5, but everything along the arrow to the right of it is. Similarly, we would use a closed dot for anything that is less than or equal to, or greater than or equal to, because in those situations, the place where we are putting the point does include our number as a solution. So for r is less than or equal to 2, 2 is a solution to that, as are all of the numbers to the left of 2 on the number line. Today we're also going to be solving some one-step inequalities that have addition and subtraction. Just as with equations, you can add the same value to each side of an inequality and have both sides of your inequality keep their relationship. And you can subtract the same value from either side of an inequality and have either side of the inequality have the same relationship. Solving equations and inequalities all follow the same steps, but there are just a few small differences in how we look at our results and do some of our steps. So if we are trying to solve q minus 2 is greater than or equal to -6, we're still going to go through those same steps. The operation that we have to undo here is subtraction, so we will do the inverse by adding 2 to both sides of this inequality. When we then add 2 on the left, our 2's cancel out to leave us with q, and then -6 plus 2 equals -4. So our inequality's solution is q is greater than or equal to -4. If we go to graph this solution to our inequality, we take a number line, and then we put a closed dot on -4 because q is greater than or equal to -4, so it can be a solution. Then we would draw an arrow to the right because that's the direction that all of the numbers that are greater than -4 would be on the number line. If your variable is written in your inequality before your number solution, the direction that your inequality sign points will be the same as your arrow. But again, that is only if your variable is written first in your inequality. Next, we're going to solve this inequality. You can pause the video to try to solve and graph d plus 9 is less than 8 on your own. How did it go? Since we see addition, we are going to undo it by subtracting 9 from both sides of our inequality. When we do that, we're left with d is less than -1. When we go to graph on a number line, we're going to put an open dot on -1. The reason for the open dot is because -1 is not less than -1, so we need to make sure it's open so we know it's not a solution. Then we go in the direction of all of the numbers that are less than -1, which would be left. The drama club can spend no more than $120 for costumes. They already spend $79. How much more can they spend for costumes? For this problem, we're going to have to first write an inequality and then solve and graph it. You can pause the video now to try to write an inequality. I recommend using words first and then writing in the numbers and symbols for your inequality. How did it go? In this problem, we saw that we had some money already spent and we had a limit for our budget. So we could take the amount that's already spent, and if we add it to the amount that we are going to continue to spend on costumes, we know that the answer can be at most $120. With that information, we just need to plug in the amount we spent, which is $79. We can use C to represent the amount spent on costumes. And for at most, I know that if it's going to be 120 at the most, then it can be 120, so I would use an equals as part of my inequality. And then it can't be more than it, so it must be less than. So 79 plus C is less than or equal to 120. You can pause the video here to try to solve this inequality and then graph it on a number line. Because we have a positive 79 being joined with C, we can undo that positive 79 by taking away 79 from both sides of our inequality. When we do this, we are left with C is less than or equal to 41. In order to graph the solution on our number line, we would have to put a closed dot at 41 and then draw an arrow to the left, since that's where the numbers are that are less than 41, showing that 41 and everything less than it are solutions to this inequality. What does this video make you wonder about solving one-step inequalities and graphing them on number lines? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learned from your failures, then you succeeded.